Hello everyone, welcome to another episode of Solving Advent of Code in Rust and trying to learn Rust in the meantime. I'm Roberto and we have
Luciano.
The other way around, sorry, which way? This way.
Luciano.
Okay, thank you everyone for following us. If you never did Advent of Code is a challenge that is published every year in the Christmas period. We are working on the last year's one. There are 24 challenges, and you can find them in this link below us. We are publishing our code in this GitHub repository, and also we have a YouTube channel where you can find all the past recordings. You can find a link in the Twitch description of this channel. Last time we were doing part 2 of exercise 19. We have a pull request to merge to address part 2 that was very similar to part 1, except that was recursive rules. Okay, do you want to share GitHub?
Yes. Do you want to go through this or should
yes,
I try?
very rapidly. The difference between part 1 is that in part 1 we were taking a string and giving back optionally a string if it was matching the rules that we had going forward. Instead, with part 2, we are taking a vector of strings and we are giving back another vector of strings because we can take multiple choices. We can take multiple routes through our rules because they also are recursive sometimes. These made the option not needed anymore because if there is no future for your solution, you just give back an empty vector, and with the empty vector, the recursion is stopping at line 46 of the data. So if the string is empty, retard strings. Strings is a vector of strings is a vector of strings, and at that point, recursion ends there. Otherwise, if there is something to work on, we go on with our rules. We try to see if which one of the strings that we have in our vector of string is good, and we go on with that one. We can have leaf rules, sequential rules, and fork rules. Fork rules, sometimes, instead of adding one string for one string, give back two strings for one string. And from this, we have the need of having vectors and not just one optional string.
Yeah, I think it's interesting to clarify that generally when you look at recursion problems, it's like a linear recursion. It's like you keep going down, but you follow one specific path. Here is like you are branching out into multiple potential paths and you need to check all the possible paths. So that's why sometimes we have vectors with multiple potential solutions up to that point. So we need to keep in mind that at a given point, we might be having to explore multiple paths.
Yeah, if we scroll down in the rule that is a fork, there we have to call ourselves twice, one on the left and one on the right rules, because rules have two parts in or between them.
Mm-hmm.
And then there is a merge of the array of the vectors that we have back. That is, scroll a little bit more.
Yeah, this one was actually greatly simplified.
Yeah, before we were doing if left, if right, if not left, if right. Now we are just taking the two routes that we went through, putting them together and giving them back as one vector.
Mm-hmm.
So it's way less code.
For that part, for sure.
Yeah. And there is just a linting, I think.
Yes. Yeah, I think it doesn't change much.
And part 2, instead of giving back a constant, we have code. The stuff in part 2 is that there are two rules, 8 and 11, that we overwrite because it's written in the README that part 2 must change those two rules. So we pass
which are the ones creating the loop in the rule set.
Yeah. Cool. So I think we can just merge this one.
Yeah. And this one solved also part 2, which we almost completed the last time, but we were finishing up a few things.
Yeah, because we tried to go through to keep the options and going to recursion and doing something, but vectors is simplifying a lot. And also for us, an empty vector is like an option known.
Okay, so do we want to look at the new exercise for
Yes,
today?
exercise 20. There is a readme. You can take a look.
So I'm gonna open it up here. Hopefully this
That
is
is
not
18.
the right readme.
No.
Number 20, please. There we go.
Okay.
Okay, so I'm gonna try to describe this one. I'm not gonna read it because it's very long. But I'm gonna try to give you like the main idea. So the main idea, at least for part one, is that we get as an input a set of tiles, and you can imagine like those are like tiles of a map, like different parts of pictures that if you put them together, you are gonna get a map. And every tile has a specific ID, and there is, let's assume that these are like pixels drawing a map where we can only get 2 values per cell, either a dot or an hash. And we get like this list with all the tiles. There are actually, our real input is really longer than this one. Now, the idea is that all these tiles, they're not necessarily rotated in the right position in the input. And the idea is that they are not ordered as well. So we should be able to reconstruct the map by looking at the tiles and by doing rotations and flipping all the different tiles until we find a match. And just to understand an example better, like with all these inputs, you should be able to rotate all the cells, like do 90 degrees rotation or flipping horizontally or vertically, and see the ones that are matching. When are they matching? For instance, if you take this one and this one, if you look, for instance, at this border and this border, they have exactly matching characters. So a dot and a dot, an hash and an hash, a dot and a dot, and so on. They are all matching. And basically, by trying to figure out matching borders, you should be able to reconstruct the entire map. This is pretty much the idea of the assignment. And then the final question is, given that every tile has an ID, a numeric ID, the final answer to the problem is that you need to take the border ones. So this one, this one, this one, and this one. And if you multiply all the IDs, this is our puzzle answer.
We have to take the corners.
We need to take the corners, yes. So this is
So
an
they are
example
always.
like you have.
So we are looking, even in our input that is bigger, we are looking for 4 tiles.
Mhm.
Okay, because the borders are always 4. Not
Yeah,
the border, the
exactly.
corners are always 4.
Exactly. I'm going to try to explain, because I was trying to think a little bit how we could implement this. So I'm going to try to share the whiteboard. Let's see if I can do it. And explain what was my idea for solving this. So basically I was thinking, just to simplify the concept, like the inside of a tile doesn't really matter, because right now we are only looking at the borders. So here I'm simplifying. Generally we have like a 10 by 10 tile. Here I'm just taking a 4 by 4 just to simplify the representation, but it should apply as well to a 10 by 10. And let's imagine that A, B, C, D is just whatever, either a dot or an hash, let's say, right? So you take this one tile, 4 by 4, and basically what you want to do is to list all the possible borders considering all rotations and flipping. So for this particular tile, what are all the possible sequences of borders that we can get? A, B, C, D, of course, D, E, F, G, and then we can get J, I, H, G, and then we can get A, L, K, J. Of course, if we keep rotating the tile, doesn't matter. We just change the position of the borders, but in a sequence, they are always going to be all the same, right? If we flip them, the interesting part is that we get the reverse string, if we want to call a border a string, for every one of them. So we will also have D, C, B, A, G, F, E, D, G, H, I, J, and J, K, L, A, right?
And we can have a combination of them, but for now we don't care. We assume that let's try the easy way. I mean, because it can be that you only flip horizontally, so you have DCBA and GHIJ, but then you still have ALKJ and DEFG. So yeah.
Yeah, I'm making a big assumption that I didn't mention. Maybe I should mention it. But given our experience with Advent of Code, we are assuming that the input data is built in such a way that we are going to have perfect matches. So whenever you find a border that matches another one, there is going to be only one. So there is not going to be any ambiguity of you need to rotate more or flip more and try to distinguish which one is going to make everything fit. I am assuming that once you find a match, that is like a perfect match and it's the only one. So
here what we want to do, an hash map between tile ID and the list of possible borders, vector of possible borders.
So I was thinking we could represent a tile struct where inside the tile struct we can store everything that is going to be useful for us, even eventually for part 2. So in a tile object, what we can store is the original tile with all the cells, but then another attribute of that could be all the borders, like all these values that we are mentioning here. And then I was also thinking that it could be useful to have a reference to the neighbors that we find over time. I'm not sure in Rust if that's easy enough to do because of references.
Yes.
We could also have another struct where we store all the matching tiles.
Yeah, in the end, the tile ID is an integer, right? So the cells nearby are a vector of integers in the end.
So this could be like a borders field, and there could be another field that is neighbors, for instance.
But we need neighbors for part 1.
We need neighbors. This is my current idea. I didn't fully explain it yet. Let's say that as we go through the list of tiles, we try to look for matching borders. Every time we find a matching border, basically we can say we can add a neighbor, for instance. For instance, if we find another one where we find this sequence here, we can get the ID of that other tile here. Let's say it's X, right? And I think there will be only 3 cases. The case where we have X1, X2, X3, and X4, which is going to be a tile in the center of the entire map. Then another case could be that we have only 3. And this is going to be a tile in the borders, excluding the corners. And then the other one is when you have only 2 neighbor tiles, and that's literally one of the 4 corners. So my idea will be that once we do all of this, we should have enough information to identify which ones are the corners. We don't really know how the entire map, like how the tiles are placed relatively to each other. Like we're not able to reconstruct the entire map so easily, I think. But for sure we can. Yeah, for sure we can tell which ones are going to be corners because we know that they only have 2 neighbors.
Okay, so we have to parse the input, create this structure with indexed by tile ID, and then do in a quadratic way, I think, in quadratic fashion. This tile, check all the other tiles, what are the neighbors, then I take the next tile, I check again, and I go on.
Yeah, I'm not sure if we can avoid the quadratic approach, but I think we can start with that.
We can start quadratic, like always. We start simple, then if there is problem with performances, we think out of something.
Cool. And I think, we'll also have a lot of fun parsing the input because
we can split on double return, carriage return. We already did this. Well, let's go to the code at this point.
Okay, so you think this idea makes sense, right?
Yes.
Okay, also disclaimer, I have a new keyboard, so you're gonna see me stumbling a lot more than usual because generally I am terrible. So it's only gonna get worse, right? Okay, so let's say the first thing that we want to do is, let's say, extract tile, right? So a tile, what does it have? Do we say cells?
Do we want to keep the ID also in the tile structure? Is useful.
I suppose it could help. I don't know.
We are replicating that in the hash map then, but who cares? It's just an integer.
Yeah, let's do it for now, and then if we see we don't need
if we
it,
see that
we
it's
can remove
useless, we remove it.
U8. I haven't done Rust in a long while. Then we said cells, and cells is gonna be an hash map. Well, sorry, it's gonna be a vec of a vec. I guess we can do like row and columns.
Can we know the size of our input? That is 10 by 10, you said.
Yes.
Is possible to create a multidimensional array of fixed size and alter it and change it, make it mutable? I mean, or do we want
Good
to
question.
with vector? It's fine with vectors. I was just asking. Was a curiosity.
I think we could do something like this.
Because we know that is an array of 100 elements.
Yes.
Arranged in 10 by 10.
So this will be a single row, and that's a valid type. And basically we need to repeat this 10 times, so it's going to be something like this, I think.
And
I think that's doable.
He's
right?
not complaining. Yeah, seems fine.
Okay, so let's try, and then if we bump into issues, we'll switch back to vectors.
Problems, like always.
And then the other one is going to be neighbors, right? Oh no, sorry, let's start with borders.
Yeah, borders.
Which is going to be...
Well, we want to do vector of string, vector of int, because the string is just 0 or 1, on and off, dot and sharp. So we want to store them as numbers, or do we want to store them as strings so it's easier to flip?
I will do it as strings for now. It feels easier.
Okay.
Or, I mean, we could also, considering that every cell could be like either a dot or an hash, I think what you're suggesting is that we could assume it's like a 0 or a 1, and we get the number, right? Is that what you're suggesting?
Yes, it's 0, 1. We get an integer, then we flip the integer binary wise. At that point, when you compare integers, it's probably, well, I don't know if it's faster.
Yeah, it might be a little bit faster, but then we have the whole issue of converting. And flipping. Yeah.
Let's go with vector of strings.
Vector of string.
String, yeah, sorry.
And that is the borders that initially is going to be empty. And then finally, what do we do? The neighbors.
There is a vector of U8.
Back of U8, yes. And it's going to be 2, 3, or 4, as we say.
Can you create a vector with a fixed maximum size? I mean, we know that maximum is 4.
You could pre-allocate capacity, yes. But only, it's not going to be like the type itself. It's going to be when you create. Yeah. Okay, so the next thing we want to do is a hash map of tiles, right? But I suppose we don't need to create a struct for that right now, right?
No, you can declare an alias of the type, but not now. If we start to write hash map of a lot of time, probably we can create an alias, but...
Exactly. Okay, so let's start with that. So let's start with let mute, let's call it tiles, I guess, which is going to be an hash map of tile. Well, it's going to be U8 and tile.
Yes.
And this is going to be hash map.new, well, column, new. And now what we want to do is the input. What we want to do is basically split by a double empty line, I think, a double slash n.
A double slash n, backslash n.
And then at this point, we can do like a for loop. So we can say for...
row tile in.
Row tile in this.
It's not snake case variables.
Oh yes. Good catch.
I don't care, to be honest, but
No, let's be idiomatic if we can. Okay, now that we have row tile there, so this is gonna give us something like this.
yes, the first line we have to parse it and take out the number.
Exactly. So we need to remove tile, space, and just take the numbers there. I wonder if we can just do a substring, because they are always like
four numbers.
digits. So
yeah, they're always 4 figures.
So maybe this is as simple as just doing a substring. So we can say tile ID.
Row tile is the wool string with
Oh yeah,
multiple
so we'll need
lines.
to take the
we
first
need to
line.
take the first line of row tile.
So
dot lines dot first.
Tile dot lines dot next dot unwrap, I think.
There is not first.
Was there? I don't remember. No.
I never remember where first is. There are iterators that have first. I don't know why this
Could be. I don't remember either. So this is gonna be the first line. So let's say
row ID.
Row ID.
And now it's complaining. For the semicolon.
And now what we want to do is to say let ID equal to row ID dot substring.
You can't slice with the square bracket, no?
I don't think so, because the UTF-8 stuff.
Right. We are always there.
I mean, it could just work, but then you could get errors. Let's see, row ID, or we could do like as bytes, and then let's try if we do this just for fun. Let's see what happens. So this will be 0 from 5 to
9.
9. So this is going to be 5 dot 9 included. Like this.
No, not included.
Expected expression found. Yeah, that works. Except, of course, you can only do like a reference there.
I don't think 9 is included, but because if you include, you take also the colon that is at the end.
Okay. Because you want 5, 6, 7, 8. Yes, you want 4 numbers. You're right. Yeah. And now, of course, what we can do is here, rather than saying that this is can be a U8, and then we can do dot parse. Dot unwrap.
Okay, always the unwrap.
Now this one should be happy enough. Yeah. Okay, so now we have the ID. Now the cells.
We have to fill the cells.
Yeah, I wonder if we can do a collect there. Let's see. So let cells is gonna be what?
Are all the other lines.
Yeah, so we need to do what did we call it? Can we get a new iterator on row tile? Let's see, row tile dot lines dot skip
1.
And then what we want to do is a map where This is, let's say, L for line. What is a line gonna look like?
The line, we can get the chars out of the line.
L dot chars.
What?
Collect. Right? And then all of that collect. Is that gonna work?
And what type is cells at this point?
So that kind of works, but of course we'll need to give type int. So let's see if it likes that, or we need to revert to cannot be built from an iterator over elements of type underscore.
Because that collect inside is giving back what?
I think we'll need to say char or vec of char.
Is an array of char in our case.
Yeah, I don't know if we can do that.
Or we convert to vec if it's too difficult.
Can we?
From iterator is not defined. Let's go to vector. Don't.
For now, let's do that. Yeah.
Vector of chars. Of char. Yes.
Now,
and change line 15.
Oh yeah. Let's change that to this.
In line 15. And try to not specify the turbo fish there to see if now that is a vector Rust is smart enough.
Yeah, it is. Nice.
Yeah, so you don't need to turbo fish that collect.
Perfect. So at this point, we should have enough to be able to build a new tile. So I'm going to do a little helper.
We need to extract the borders.
I'm going to do that here, I guess.
Okay.
Does it make sense to you that we do a fn new, and what we want is an ID, U8, and cells, and then everything else we can calculate ourselves?
Yes.
That returns a new self. And basically what we do is we just need to calculate borders first. So let mute borders equal to, so this is going to be a vec
of string.
And initial is going to be empty. Now, the first border is literally the first line. Right? In the cells.
We have the cells as a vector of vectors. So now we have to take the first line and the last line, and the first column and the last column.
I'm thinking, does it make sense to have these two types different? Like, I mean, this one and this. And this, I guess.
Is a vector of char.
Yeah, either we do both as a string or both as a vector of char.
Okay, convert the border to vec of chars, but it's a different vec of chars.
Yeah, it's going to be different, of course. I'm just saying that maybe it's easier for now to keep the same.
Cool.
Types.
I'm fine with it.
Ooh, of course we're not returning yet. Okay, so now let's start to put borders dot push, I guess. And what do we want to push is
we can
cells.
Push the first of cells, the last of cells that are the two rows, the first and the last row.
So perfect. 0 dot, do we need to clone?
No idea.
Let's see if we don't clone what happens.
I would complain like crazy.
Wait. Oh yeah, I didn't change the type here. Back. Yeah. Okay. Then the last one.
The last one.
Dot push cells. I don't know if you can do -1. That would be interesting.
You do cells len -1.
That's gonna work for sure. I was wondering if you can do like Python. That sometimes it's nice.
I can't answer your question. Now the vertical ones are a little bit more tricky.
For instance, we want all the column 0 and column 10 or len, whatever it
We
is.
can prepare two different vec of char. That is left and right. Then we can do a for I to 0 to 9 or 0 to 10, so 10 times.
You know what? I'm gonna call this let top, because we will also need to reverse all of this, so maybe it's easier if we do that.
Yeah, top, bottom, left, and right.
It's also a little bit more explicit, I think. And then we do let mute, or we can maybe do it with collect.
We can do that with the map. You're right.
Yeah, let's do it in one go. Left.
Let left is chars dot map cells dot map, and we just take the first element because it's left.
Exactly. So this is gonna be a row, I guess.
Yeah, that is a row.
And we take row 0
because it's the left one, and we need to collect or.
And we need to collect. And we need to collect as a vec of char.
And right is the same, but we take the last element instead of the.
Does it like it? Oh, we need either. The usual stuff we forget.
Yeah, the fact that you can't map on top of a vector still doesn't fit in my mind. I don't know why. For me, a vector is iterable by nature.
By the way, I want to try also this thing. I think it might be able to infer that char bit. And now we want to get cells.len -1.
R.len.
Actually, yeah. We know it's
they are square,
but,
so nothing changes, to be honest.
But this is more correct. You are right. So this is going to work also with rectangular ones.
That we don't
this
have.
This is nice. It works. Okay, so now we have top, bottom, left, and right. We also need to flip them. Now let's see.
We can add them to borders. Then can we flip in place a vector in Rust? Reverse.
Reverse.
Flip a reverse.
Yeah, there is a reverse.
It works in place or give you back a new vector?
I think it works in place because it wants a mutable reference. Look at that reverse. It wants a mute self, so it's gonna. We need to clone and reverse basically.
Okay, so we have to clone and reverse and add to borders.
So what we can do is basically do this. Just if we want to keep r top equal top dot clone
reverse
dot reverse, and we can do that for every single one.
But reverse is returning self or not?
Oh, good question.
So we have to say that r top is top clone, then r top reverse.
No, it doesn't return anything. You see, it's a unit type. So
put a semicolon after the clone, and then r top reverse. Yeah, exactly. But there is a better. Guys, if you know better ways in the chat, tell us. This is working. It's just ugly.
By the way, I'm not minding the chat, so if you see anything, let me know.
There is a new subscriber, Marco Antonio Dev.
Thank you, Marco Antonio. So clone, and then our bottom dot reverse, and we do the same. Good exercise for my new keyboard. So we do left.
But why do you change the keyboard?
I don't know. Compulsive shock, I guess.
It's like the soccer team. You don't change it.
Exactly. So here we have right,
let
equal right dot clone, and then right dot reverse. No. Cool. And now what we do?
You're missing a E.
catch.
And then we have to push them inside.
At this point, what I want to do is this.
Okay, you
So
create the
we
vector.
avoid the push, basically.
But at this
This
point
is
also,
literally
it doesn't need to be mutable.
top. Actually, yeah, good point.
Because we create it like it must be.
Top or top, bottom or bottom.
We don't care about the order of them for now. We just check if they exist in somewhere else.
I don't think we care.
And the linter did the magics. Okay.
Okay, as long as it's happy with that. So now we can return a new tile, and we know what to put in this tile. The ID is ID. Then cells is cells, so we can leave it as it is. Borders is borders.
Also ID, we can leave it like it is.
Oh, yes, you're right. Cool.
And now, vector and neighbors, we are not computing neighbors because now we can't, because we don't have enough informations to compute the neighbors while we parse the tiles.
Okay, so this one is clone, I think, the issue, and we'll probably need to do this everywhere. Why it doesn't like... Oh, because this needs to be mutable. Lots of fun. Oh. Mute.
Lot of mute, lot of clone. The collect is cloning, probably.
Interesting. Could be. I didn't expect that, to be honest, but whatever. He would have complained otherwise.
Magic.
Okay, so at this point, I think what we can do is if we implement, if we derive, implement, debug, I think we can try to parse.
It's not lowercase? Okay.
Yeah. Yes, this one is uppercase.
Yeah.
Now we can try to print everything, basically, and see if that makes sense. Right? I mean, we haven't done anything here. What we need to do is to create a new tile. So what we can do is let tile equal tile new, and we need to pass ID and cells. That's it.
Then we can print a tile with the...
And then we do print. Actually, let's do dbg because I like it more. Tile. So we don't need to use the format string.
Okay.
And now if we run the test one, we will see a very verbose output, probably. No.
Instead, we see an error.
Position overflow. What is that? Which line are we failing?
41.
41. What do we do in line 41? Oh, maybe
our ID from 5 to 9. Can we debug row ID from 5 to 9?
Yes.
To see what we have there, because probably it's not a number for some reason.
So if we do print, let's do dbg again of this.
Can you dbg as the expression?
I was hoping for. Okay, let's dbg a reference. Yes, we can do that. Now, if we rerun this guy, we should see... Oh, okay, no, this is correct. 3011, is that the first one? Yes.
3011 to me seems a valid number. So what is complaining about? Panic when calling unwrap. Because it's not a U8. It's a U16.
Oh, of course. Why did we do U8 in the first place?
Because there are not a lot of tiles. So our brain said, oh, they have less than 256 tiles. Let's use a U8. Yes, but the numbers are bigger.
So let's do U16 everywhere, and this is going to be a U16.
You can search and replace because...
Yeah, fair enough. And this is going to be a U16. Now, let's remove this one because I'm confident it's going to work.
Yeah, okay.
Lots of stuff. It did fail eventually.
Again. unwrap of known.
That might be because we have empty lines in the input at the
That
end.
can be the end. We have empty. If you go to the very end, we have multiple.
Yeah, we
Remove
do.
one carriage. Remove all the carriage return. So stay with only the lines until 1727.
I think what we
Or-
could do is
Basically, we got an empty row tile.
yeah. How do we remove the last two? I mean, the last. Is there like you
Okay,
can
there
do
is
skip?
yeah, there is the equivalent of skip, but the other way around. So until
Please
no.
unzip. Let's see what we have.
That one, what kind of type it is?
We
An
could have
iterable?
used filter. Yeah, that's an iterator. What you get with split. Intersperse. I have no idea what that is. Last. Oh, there is a last.
Yeah, but we
There
don't
isn't a
want the
first,
last.
but there is a last. No, because you mentioned, is there a first? There isn't, but there is a last.
It's possible that there is a last, but there isn't a first.
Clickable position, reduce, rev, scan, skip while. There is a skip while, but that's still. Oh, there is take and take while. So we could probably say take while that string is not empty, right?
Yes,
Take.
until probably there is only one carriage return there or stuff like that.
So if we say t empty, is that empty? Is empty. So while is not empty. Is that gonna work? So that should skip the last one if we are doing the right
If it
thing.
is empty, if it has only one carriage
Yeah.
return, no, it's just skipping because cool. And they must be 100. How many were they? 144 tiles.
How do we know?
Let's put them in the
Yeah,
hash
we
map,
can
and
put
then
them
we
in
do
the
a,
hash map and count
then we
the
do a len
number
of
of
the hash
keys.
map.
So now what we want to do is tile dot, I suppose, insert or push.
Tiles.
Tiles dot insert.
That,
The key is ID and the tile is tile.
okay.
Now
dbg tiles len after the loop. Because
otherwise we'll print a bunch of stuff for nothing. dbg tiles.
So now, if everything is fine, we have 144 tiles. No.
Oh, expect.
There is
Yes,
still a new
I
weight
forgot
somewhere.
U16.
Rust is so peaky.
144. So we have
What we
12 by
expect.
12 probably.
Yeah, our problem means 12 by 12. Now we have to compute the neighbors of every cell. We start with the quadratic way. In the end,
So
144 is not a huge number.
So basically what we want to do
Is
I
for
wonder
every
if
tile.
we can do like a mutable iteration where inside the iteration you change the hash set itself. We can try.
Okay.
So basically what we do, we have for ID tile in tiles, right? Tiles dot either, I guess.
The tiles was enough because it was happy. It was unpacking. I don't know if like this we are consuming tiles or not. But for now we don't care.
Don't know. We'll
Or
see.
we care. Can we modify tile?
I think we are because here it's complaining. So we need to do either. Okay, this way we're not consuming it.
Okay. And if you were putting a reference in front of tiles, was not working.
Maybe. Yeah, that works as well. Probably it's doing the same thing.
Now,
Okay.
can we change tile? Because now we have to change tile.
Now we need to change one tile. So for instance, we can have tile.neighbors.push.
.push.
I
Yes.
don't know, 22.
1. Yeah, random number. It's complaining that tile is unmutable. Cannot borrow as mutable. How
Can
can
we do this?
borrow as mutable?
Oh yeah, we can do that.
Okay. Now, what we have to do is doing another loop inside this loop that is looking in all the tiles that is not ID, because
Yes.
obviously we match with ourselves, but we don't care.
And
see if there is a tile that match one of our border with one of these borders. At that point,
so what I will do is probably like is neighbor.
And you pass another cell.
And we pass a self.
A tile, not a cell.
And then another tile. So tile, if we can type, and a reference to a tile. And that will return a boolean.
And this will return a boolean. Okay.
And then basically what we do in our loop is going to be for every couple of cells, if it's neighbor, we add it to the neighbor list.
Yes. And this if we want to write it, is does any of my border match with any of his border? Okay. Basically, there are two sets, and you do a set intersection. If the intersection give you at least one element, the border are matching.
I'm thinking that actually, can we use a Nash set here for borders?
A Nash set of vector of chars, but a vector of chars is mutable. Typically, you can't hash something that is mutable. I don't know if Rust has a way to hash that. For example, if it was Python, the list is not hashable type because the list can change.
That's true.
Let's do the bad way. So for all my borders, does the other contains this one retard?
Yeah, because also as long as we find one, it's fine. We can stop early.
We stop there.
So
and at the end of the loop, retard false because it's the case with for nothing. For
border in
self borders,
basically what we want to do
if tile
is
dot borders dot contains, there is a contains, right?
There is. I just saw it. And now
border.
It wants a reference, so we need to say border, I think. Then return true.
Yes.
Otherwise,
and
return
out
false.
of the loop, we return false. Now, we are doing a contains. Okay, why is complaining?
The usual, I think. Yeah. And now we just do this. And of course, we are not using that, so it's complaining.
Cool. Now it's doing contains with a vector inside a vector of vector. I hope it's working, but we'll see.
Yeah.
Now we do another loop exactly like you did one you did, but not mutable this time.
Don't know. So when do we find a neighbor? Do we need to change both tiles, like the current tile and the outer and the inner one?
If you do that, we have to change the loop to just do from now on. Because otherwise, when you land in the one that you already checked, you are adding again the first one as neighbor.
Right, but in order to do that, you need to have like indices, like with enumerate.
But this is an hash map, so I don't know if you can do that. Let's go the dirty way.
Yeah, let's go the ugly way, and then we'll see.
So now we have ID of the other and tile of the other, and it's not mutable. It's just a reference.
So what do we call it? Do we call it other ID, I guess?
Other ID, other tile for now. Better naming are accepted. And it's not reference mutable, but just reference.
Mm-hmm.
Now,
and now, of course,
tile
if ID, well, first of all, if ID is different, ID is different than other ID, right?
Yes, if it is another one, and tile dot how it was
is neighbor
of other tile. So at
what
this point, tile dot neighbors dot push
other neighbor dot ID.
Other neighbor ID.
Other tile, sorry.
But there is another ID that is the ID of the other tile. They must be the same, but
yes, you're right.
I think they are the same. We added.
I mean, if we did everything correctly, yes.
But
expected U16 found a reference.
You have to materialize the U16 with a star.
I suppose. No, cannot borrow tiles as immutable.
Why?
Tiles as immutable. Oh, the opposite. This is immutable and this is mutable.
But no, we are pushing 2 tiles. We are pushing 2 tile, so it's tile that must be immutable.
But maybe it's figuring out that it's the same.
So
we need mutable in both places, which is I don't think it's going to be happy with.
No, he's complaining again. Cannot borrow tiles as mutable more than once. Okay, so it can be mutable the second time. Okay, so remove mutable from the second loop. And what is complaining about now? Cannot borrow tile as immutable because it's also borrowed as mutable. So we are borrowing it as mutable. We can't borrow twice. So you can't loop twice inside an hash map in Rust. Make no sense. Try to do iter like you were suggesting before at this point. There, instead of borrowing, then do tiles.iter.
I think we'll have the same problem.
Okay, if you do iter mute in line 61 now, instead of...
I think it's going to be the same if I understand the idea. So I expect the same error.
Okay. So let's take it easy. We want
we could rebuild another set of tiles, like tiles with neighbors.
Parsing again the input, you mean?
No. That we start with an empty hash map of tiles, and then we push to that. So basically, we have...
how this is going to change our problem?
Because at that point, we never mutate the original tiles. We have another tiles, like tiles with neighbors, something like that.
And if you don't mute them, you can iter 2 times?
I think so, yeah.
Okay.
Because the issue is that when you have a mutable reference, there can be only one reference.
I have another suggestion. Before these 2 loops that are one inside the other, we create a vector of U16 with all the IDs of our tiles. Being a vector, the order will be always the same. Then we say what you were saying. We start with the first one and all the one that follow. We go to the second one and all the one that follow. Third one and all the one that follow. So instead of doing a square, we do a triangle. And when we find a match, we add the neighbors on both tiles, the other tiles and the tile. At that
Another
point, we have a
idea-
double loop on a vector that I hope is possible. And then we reference the object in the hash map with the key.
Yes, another idea that I have is that we could have the neighbors in another hash map. So rather than having them as an element of tile, we never modify the tiles. We just keep the neighbors with another hash map of ID and the neighboring IDs.
So ID to vector of ID. So
I think that's
U16 to
actually
vector.
simpler.
I was preferring to keep the neighbors inside the tile, but I'm fine to go for this direction for the sake of simplicity.
Yeah, I think it's going to be simpler. So we never mutate the tiles.
Yeah, we never
basically.
mutate the tile.
So that should be it for that. And now we need to start creating like neighbors.
A neighbor hash map that is a U16.
So let mute neighbors lowercase. It's, let's say, a hash map of U16 to
vector of U16.
Of U16.
You lack a closed angular bracket, I think.
Oh my god, I'm doing a mess.
You lack
lacking,
closed,
yes.
Yeah.
Good catch. Yeah. And now here, what we want to do is basically neighbors.
Neighbors of ID.
Of ID. And
there is a way to do that in one step.
There is
get or default. No, it was insert or default. No, I don't remember.
We did that multiple times.
Yes, but I can't remember the or default. Searching all the code default. It will be no. Search Control Shift F.
1 second.
Or default.
Oh, it's going inside our flame charts.
Oh my
Can
God.
we limit to a particular files to include ORS? Or
default. Yeah, or default one.
That was entry or default. Okay.
Okay, entry or default push. Yeah, it is what we want to do. Neighbor of ID entry.
And then dot.
It's not key.
Or
it's
default
ID.
is, you're right. ID.
Okay. Or default dot push.
And the value is other ID. Now, in a similar way, we could also do the opposite, right?
And now it's complaining. Why?
References.
Okay.
Is it
No.
or not? Oh, no.
You have to materialize it, star.
Wait, because we are still doing...
Data.
Let's revert. We want this and this again, because we don't want to consume.
Yeah, but
now
they are still...
Yeah, we need to the reference.
The reference? Materialize, I don't know how it's called exactly. Okay, and now
this is already a reference.
Okay.
So that should be it. We can also do the opposite if you want. Oh, are we going to get duplicates if we do the opposite?
If we do we can do a hash map of not
or this could be like an hash
set. And then at this point we do... No, it's not push, it's add.
We need to import.
Is add instead of push when it's a set. I don't remember.
Insert.
I don't remember.
Insert.
Okay.
And now we can do the opposite. So we can do entry other ID and ID.
At this point, even if there are duplicates, fine, they will overwrite.
Now I'm curious to see our list of neighbors, just to see if it explodes. And we should see
We should see one entry with only 2 neighbors. 4 entries.
4 entries, yeah. So 4, 4, 4, 4, 4.
Some have 3. I saw some of them with 3.
Mm-hmm.
Can you filter by that?
I mean, we
filter
can keep scrolling, but there are 3. I mean, we can try to solve it, right? We can try to say corners.
Filter?
At this point, what we want is this: let corners is equal to neighbors dot.
Filter? Can we filter them?
Filter? No, we need an iterator over iter, and then we get filter, and basically we have
key evaluate,
key that we can ignore and value. No, we need the key.
No, we don't need the key. No, we just need the value.
No, because the key is going to be the name of the corner, right?
But well, it's not in our corners. Even it's not needed for the filter. It's needed for the collect. But
yeah, exactly. So ID, we need to return the IDs.
No, we need to return true or false here in the filter.
You're right. We need to return
underline underscore comma value.
You know what? If we do a filter map.
Okay.
And here we have key value.
Okay, now it makes sense in value. If len is 2.
So if val dot len is equal 2,
we return
then we return some
key.
Otherwise, we return none. What did I do?
Where are you? It's the linter that kicks randomly.
No, I think I clicked the wrong button. So
and also
totally my fault. And at this point, I think at this point we can just return product, right? We can do collect product.
Collect product, see, yes.
And that's gonna be why doesn't like filter map? Single tuple. Oh, we need parentheses. Now collect as back of U16. No?
Because it's a reference to U16.
A reference. Some is a product. Why doesn't like it?
Iter product.
Really?
Put an iter in front of product.
Oh, maybe we don't need to do collect. Maybe we just need to do product.
Try to remove collect. And now we have to.
That doesn't work because you probably need to tell it as a U16. Okay. And now if we return corners, is that going to work? Let's see if we solved part 1 just in about 1 hour.
As a U64. The product is a U64.
No, I think it's what we promise is a U64.
Yeah, but it's a big number. Look at the comment in 7.7.
Now this is not gonna like it. Some key as U64.
Because if you multiply U16 between them, they can get huge.
Yeah. So that, let's see if that works. Nice, that worked.
So yes, they are kind with us with the input, and they don't have strange behaviors.
So I'm gonna add a quick comment here just to remember. Corner tiles will only have 2 neighbors, and this is literally what we do there.
Yeah.
Cool. I think I will call it a day. We commit this stuff, and then next time we'll continue with the second part. What do you think?
Yes, I think we can wrap it up. So you can find the recording on YouTube. The link is on Twitch in the About section. If you're watching this on YouTube, we do the live streaming on Twitch every Monday at 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description and give us a follow, like, and everything else. Feel free to leave comment, open PRs. The repository is in the banner down below, github.com. Everything is accepted. We are trying to learn Rust, so don't expect this solution to be beautiful, to be fast, to be optimized, to be idiomatic. We try, but not always we achieve it. If you know something, tell us, leave comments and everything else. Thank you for all the suggestion, collaboration, and so on. Are we writing somebody?
Nope, I'm not
No.
ready for that, so we are not ready.
We are not
Next time.
writing.
Exactly.
Thank you, everybody, and see you next time.
Bye-bye.
Bye.